All right. Good afternoon, everyone. Welcome to the session on microgrid technology, engineering, and modeling breakthroughs. My name is Ashray Manur, and I'll be the moderator this afternoon. I'm a research associate at the UW-Madison College of Engineering, where I got my PhD in electrical engineering with a focus on microgrids. My research focuses on developing tools and platforms to use microgrids in energy storage for a wide number of applications, from rural electrification in India to energy resilience in the US. I'm very excited about today's session on microgrids, sponsored by Xcel Energy. This technology is gathering a lot of interest in both academia and industry, and we're seeing a lot of pilots all over the world. And the question is, how do you go from pilots to commercial deployment? What are the technical, policy, and implementation challenges and opportunities for microgrids? And how does this work in Wisconsin and Midwest? That's the theme of our session today. We have a fantastic panel of speakers. Let me tell you how this is going to work. I'm going to first introduce all the speakers. Each speaker will then have about 5 minutes for opening remarks. I will then start our discussion with a few questions to the panel, and then we'll take questions from the audience. So at any point, if you have any questions or comments, feel free to put it in the chat window. And you might also be seeing a poll, and the poll is what best describes your industry. Feel free to fill that in and submit that answer so we get a sense of who's in the audience. So let me introduce the speakers. Our first speaker is Amy Simpkins, CEO of muGrid Analytics. As CEO of muGrid Analytics, Amy Simpkins solves wicked problems at the intersection of energy, technology, and economics using math and modeling. muGrid provides bankable techno-economic analysis, optimized control, and project development of renewable energy, energy storage, and microgrids to maximize economic return, increase energy resilience, and promote energy equity in the US and around the world. Prior to muGrid, Amy designed and operated spacecraft, microgrids in space, as a systems engineer with Lockheed Martin. Welcome, Amy. Our next speaker is Don Wingate, Vice President, Microgrid Solutions and Strategic Alliances at Schneider Electric. Don leads the North American business development efforts for microgrid solutions and also manages the power and grid segment focused on strategic electricity company accounts. Mr. Wingate assisted in the architecture and launch of the Schneider Electric Microgrid Competency Center and is the sponsor for the development of channels and alliances for microgrid projects. Prior to joining Schneider Electric, Don held executive and management positions at Logica Inc., Capgemini, Oracle, and General Electric. Thanks for joining us, Don. Our third speaker is Deb Erwin, Manager, Regulatory Policy at Xcel Energy. Deb works on a variety of regulatory issues for Xcel Energy related to renewable energy and new technologies, including Xcel Energy's Solar Garden program, Solar Connect community, and Xcel Energy's new renewable program in Wisconsin, Renewable Connect. Prior to joining Xcel Energy in 2014, Deb worked for the Public Service Commission of Wisconsin, where she focused on renewable energy and regional energy markets. Before joining the commission in 2008, Deb practiced the renewable energy law, working on community-based wind projects across the Midwest. So welcome to all the speakers. Thank you for joining us today. I'm going to first invite Amy to give the opening remarks, followed by Don and Deb. Amy, the virtual floor is yours.
Thank you so much, Ashray, for that introduction. That's wonderful. Yes, I am the CEO here at muGrid Analytics, and I'm pleased to be leading off here to kind of give you an introduction into microgrids. What is it that we mean when we talk about microgrids? What are the various components of microgrids and how they work all together for your advantage at a site. So let me just share an image here. The beauty of microgrids here, when we talk about microgrids at muGrid Analytics, we are talking about resilient, grid-connected microgrids. So microgrid being a collection of energy assets that's working all together to provide energy to a site that's separate from the larger utility grid. But when we talk about the resilience word and the grid connected word, we're talking about really important features of that microgrid. So the first thing we want to talk about in terms of features is that resilience piece. So a lot of entities, a lot of people, commercial organizations, towns, critical infrastructure is looking at installing microgrids in order to provide resilience, to be able to stay up when the grid goes down. Where historically we may have seen purpose-built resilient infrastructure such as UPSs, automatic switchover, and large generator plants to keep critical facilities running. We're starting to ask with this onset of renewables, of distributed energy resources of all stripes, how can we use those assets, not just for the benefits of resilience and be greener during resilient mode, but also maybe get some other benefits. And that brings us to the second feature, and that's the grid connected part. And so unlike traditional backup infrastructure like pure generator or pure UPS, grid connected microgrids can be used for economic benefits when in grid connected mode. And that should be a win-win situation for a site as well as for the utility. And we're seeing that as, and I think you're going to hear from Deb as a representative of a utility that, you know, we are incentivized as the consumers to behave certain ways by our rate tariffs and by other incentive programs, which are designed to say, hey, yeah, like the utility would like to see us have more distributed generation, more storage, so we can put the energy where they need it too. So it should be a win-win situation between the utility and the consumer, and there can be compensation for that. So when we look at these resilient grid connected microgrids, we really see three main pieces of technology, three categories, and they work all in symbiosis. And any one of them on their own doesn't really do the job, the full job as this resilient grid connected microgrid, but working all together, you get advantages so that the whole is really truly greater than the sum of the parts. So starting at the top here of the diagram, we have renewable generation, and you know, kind of the easiest renewable generation that's inexpensive, it's easy to see how it works, it's tried and tested technology is solar. But we can also talk about renewable generation from other sources, including hydro, wind, geothermal, biomass, and that's dependent on you know, where you are in the country, where you are in the state, what's available around you. But renewable generation for the microgrid provides both sustainability and survivability. So when I say sustainability, I mean that renewable energy, that it's green, it's good for the planet, it's a renewable resource, but also survivability, that because they're renewable resources, that energy is always there. You're never going to run out of fuel because it is renewable. And so that element of survivability is not there in other traditional generation resources. However, the generation coming from those renewable resources can be intermittent depending on weather, climate, seasonality. And so that's why we pair it with firm generation. That'd be your traditional diesel, fossil fuel generators, or it doesn't even have to be fossil fuels. It could be carbon-based fuels. And maybe in the future, we'll see even more advances of fuels. But firm generation would be a generator that's able to be started and stopped at will, right exactly when you need it. And so that's something that you can't do with renewable generation that's intermittent. And the thing that ties it all together is energy storage. And energy storage provides both control and efficiency. It's control because it puts that renewable generation exactly where you want it, both in grid connected mode for economic benefits and in resilience mode when you're trying to help those intermittent renewable resources have smoother performance so they can integrate well with firm generation. And finally, that energy storage is also providing efficiency to help that firm generation run at its maximum capacity so that you are able to maximize your resilience, maximize your economic returns, which you would not have an economic return for firm generation alone that would not operate during a grid connected mode. So that both economically and in a resilience mode, you get more bang for your buck out of all of your generation resources. So that is my quick 5-minute overview of resilient grid connected microgrids and what we hope to talk about today.
Thank you, Amy. Don, the floor is yours.
Yeah, I think Amy has to stop sharing. Okay, there we go here. Let's see if I can find my slides. All right. So Amy did a really good job of talking about microgrids, and I think the watchwords from our perspective is resilience, and that's what is the next thing that's people are really talking about. I come from Schneider Electric, and I want to just remind people that might not be familiar with us. We're a pretty large global company, and we really just focus on energy automation, efficiency, and sustainability. Schneider doesn't make anything that generates an electron. We don't make photovoltaics, we don't make chemistry, we don't make rotating equipment, but all those controls and integration that Amy talked about, Schneider's very much involved with. My picture is very similar to what Amy had. And so I don't want to go over the different components because she did a really good job of explaining different things. So I want to emphasize the importance of interconnecting appropriately with the utility. While we focus a lot at Schneider with behind the meter microgrids, every single one of them that we do is grid tied. And we think that it's really important to collaborate with the utility to get the best activities and the best controls, the best safety with the utility, and make these microgrids very, very effective to give you those benefits that we've been talking about. And every time we speak to a customer, there's three things that always come to front of mind. People want to take more control of their energy outcomes. This word prosumer is starting to really gain traction where you're producing and consuming your own energy. And people want to talk about cost, whether that's a lower cost or whether it's a predictable cost. How do you make sure you look at the fuel costs more effectively? So top of mind always is, let's make sure things are done more cost effectively. Resilience is the second thing we always talk about, and that's about figuring out how do you just make sure that you're up and operational. How do you, whether it's your home, whether it's your business, just make sure that you're more resilient, both from a availability of power, but also from a power quality perspective. And the third leg of the stool is sustainability. When we survey the Fortune 500 companies in the United States, 90% of the CEOs have sustainability tied to their compensation. If you look at new buildings that are being constructed, it's brand value. People want to go to sustainable places of business. So it's going to improve your bottom line and improve your shareholder value. Those that are into finance, if you look at companies like BlackRock, they are putting a premium. If you don't have a sustainability plan as a company, you're not going to get financing. So those things all put together. And the microgrids have to look at those foundational components, but it's not just about the sources of generation, whether it be wind, photovoltaic, storage. You have to look at the uses of energy as well. How do you make sure your commercial facilities are more efficient? Size your building properly, make sure you're efficient, then supplement it with microgrid technology and on-site generation. The last piece that I'll talk about is, we try and make things simple, right? We view it as the integration to the grid, the control of your resources are really important. So you need that control software, the control hardware to integrate all the different sources of energy and uses of energy. Then you have to make sure that you operate effectively. So the edge control makes sure that you are islanding properly so that when there's transitions that occur, whether it be for outages or economic advantages, when you island from the grid, you've got to do that effectively. And then you've got to orchestrate with algorithms and software to make sure that you optimize every asset. How do you, like Amy talked about, people that had purpose-built integration where there might be some UPS or generation. How do you make sure those are not stranded assets? use them every day in the best possible fashion, use all your assets to their optimal availability, and make sure that it works. So that's me. Looking forward to the question and answer session. So thanks very much, and back to you.
Thank you, Don. Deb, the floor is yours.
I think, Deb, you're still on mute here.
Sorry, I got ahead of myself. All right. Are you guys seeing my slides yet? No, I didn't do that. There we go. All right.
There you go. Perfect, Deb.
Okay, we're good to go. Sorry about that, guys. You would think this was the first time I was doing that. This is not the case. So thank you all for the opportunity to talk about this today. I'm gonna just talk a little bit about who Xcel Energy is and then what we are trying to do in this space to advance things. So if you are not familiar, Xcel Energy is an investor-owned utility that operates in 8 states. Wisconsin is one of those states, but certainly not the only one. In Wisconsin, we are in the northwestern part of the state and do have some service territory in the UP of Michigan as well, just to kind of orient you. You know, one of the reasons why I'm here today talking about microgrids is because they fit really well with Xcel Energy's strategic priorities. Those are shown here. It's to lead the clean energy transition, enhance the customer experience, and keep bills low. And really, I think resiliency and microgrids are ways to accomplish all of these priorities, as well as many priorities that individual customers or policymakers may have as well. So it was mentioned a bit earlier, but we have recently proposed a program in Wisconsin that's pending in front of the Wisconsin Commission to provide resiliency services to customers, and wanted to talk a little bit about that to provide some background. So really our end goal here was to do all of the things that Amy and Don have talked about, you know, to be able to provide these types of benefits to large customers and enable the development of these types of projects. And so, you know, the main goal of that ultimately being to make this not only enable, but make it convenient and affordable as much as we can. And I'll talk a little bit about that so that, you know, customers in particular, we're starting with larger customers who may have an interest in increased resiliency. So that main goal then translates into many other goals that we had as we thought about from the utility perspective. What can we do? What should we do? What do we need to do in order to help our customers have increased resiliency? You know, things that we think about from the utility perspective include avoiding subsidization from other customers. You know, we can't have increased resiliency provided to one customer at the expense of all other customers, right? If there's not sort of a benefit also being provided to those other customers. And we wanted to do something that is fair, that, you know, a variety of customers could participate in. And then, you know, there's a lot about these projects, which you could probably start to gather from the descriptions that Amy and Don provided, that are very complex. I mean, all resiliency projects, all microgrids are custom projects, right? I mean, at some point, clearly there is some level of consistency and things that can be replicated, but nothing is just plug and play, at least not when it comes to larger customers. You need to be able to address those things sort of on a custom basis. We also really wanted to be sort of technology and provider, you know, manufacturer, et cetera, neutral. So I'll talk a little bit more, we can talk more in the Q&A about how we did that. But, you know, while many customers may be interested in solar and batteries, other customers may have really good applications for other different types of generation, right? And so we didn't want to just sort of pick a technology. We wanted to make something that would be technology neutral. We wanted to be able to also maximize the benefits of these to the customers who might participate in this new program, while also minimizing sort of the costs associated with actually providing this to those customers. So what that got us is a program that we have proposed as a pilot. Xcel Energy has proposed as a pilot in Wisconsin, where a customer could come to the utility and ask for a resiliency project where the utility would own resiliency assets, but the customer could also bring their own assets to this. And this was something that we realized fairly early on as we were working on this, that many customers that might be interested in developing a microgrid might already have existing generation, for example. And so we didn't want to exclude those types of customers by sort of saying this is you have to buy all your stuff from us. So we're not saying that at all, actually. But to the extent that that is helpful, and one of the things we're trying to do is lower the upfront costs associated with developing a microgrid, you can ask Xcel Energy to own those types of assets and then pay for them on your utility bill under a 10-year contract. And so we found that that upfront cost is a barrier to customers doing projects. And so that was one of the things we were particularly trying to address. Again, wanted to be able to do custom projects that really could do whatever it is that the customer might want to do. But we did propose this as a pilot at this point with a proposed cap of 30 megawatts. Just a couple quick notes, as we worked on developing this, we talked to a number of customers that we have already in Wisconsin that had expressed interest in microgrid projects. Some of them have been expressing this interest for a number of years, and others are newer. But just to try to get a sense of what types of projects might be out there in Wisconsin, at least in our service territory, and what they might look like. And conversations with a number of these customers really directly informed our development of this proposed program. And then the last thing I'll say before I turn it back is, we have to get creative here as we're trying to move along to enable these types of projects. But there are a number of new approaches that can enable microgrids. So, we'll talk more about this, but the role of the utility continues to evolve. And I think, of course, this is a good thing. I think there's a lot of things that can change that are for everyone's benefit. And some of those things are directly applicable to microgrid development. I also have to say that this is incredibly complicated. This is, I've worked on a lot of different customer programs that Xcel Energy has proposed. This is the most complicated one I have worked on, and the longest filing, the most detailed filing, that sort of thing. And so we try to think through as much as we possibly can ahead of time, but I'm sure we didn't think of everything, right? But we're all learning as we go here. And so hopefully we're pointed in the right direction. But if you do want more information, I put the docket up for the Wisconsin Commission. We're hoping that they will make a decision on this proposal maybe yet this spring. We also do have a pending request for qualifications out right now. We don't already have all of the skills and supply chain developed to be able to provide microgrids at the drop of a hat to our customers. And so we are planning to contract with a number of other entities to provide this as a service, and so have an open RFQ pending, which responses are due by February 1st. So if you're interested in that, you can check out the website or follow up with me afterwards. Thanks.
Thank you. Here,
We have some technical difficulties, Ashray.
Amy,
There we go.
I'm sorry. Or no?
Ashray, why don't you let me ask one question and see if your internet clears up. This is something that Ashray proposed when we were preparing for the conversation, and he said that microgrids come in all shapes and sizes, and some of our speakers referred to that as well. Could you talk a little bit about the challenges, roadblocks, and opportunities for technology development to solve context-aware needs? And this question is for Amy, and then Don and Deb can weigh in as well.
Sure, thanks. And to start out and talk about, I'm going to talk about two challenges here. And one is what Deb touched on, which is like the uniqueness and customization required for every new microgrid. And the second thing is talking about the valuation of all of the value streams, including resilience. So, so first to the uniqueness, Deb said it already. Every microgrid is unique. I noticed that on Don's slides, he referenced Navigant, or the artist formerly known as Navigant. There's a famous quote out of Navigant that if you've seen one microgrid, you've seen one microgrid. And we live and die by that here at muGrid Analytics, and we customize absolutely all of our analysis. And that does present some challenges, you know, between the economics piece is really about how yours or one building's specific load profile interacts with that specific rate tariff. And you change any of those parameters and the system changes. And then you combine that with the way that local weather and climatology affects not only the renewable generation potential, but also the load. And you've got every site is just a snowflake. It really is a fingerprint. And so the way that we view that as an opportunity here at muGrid is that instead of looking for rules of thumb like, oh, if you have this much peak load, you should have this much battery inverter. And if you have this much annual usage paired with this much, you know, and these like, you know, little, you know, small calculations, we view the commonalities between microgrids as the methodology. We try to standardize our methodology around how we approach resilient microgrid design and economic microgrid design, and the design processes, the design approaches, and then following in operations, the control processes and approaches are consistent, are common, even if the answer for every single site is still unique. The second thing I want to talk about really quick here is the valuation. And I noticed that, you know, Don started out with the most important thing is resilience. And I agree with that on a conceptual level, but really how projects get done is cost justification and economics. And so bringing the valuation of that resilience into the economic picture is really critical. And we haven't done that as a community yet. There have been several suggestions as to how to do that. And in some sectors like manufacturing, it can be, quote, easy to estimate, you know, how much downtime affects the bottom line. Okay, now you have an economic metric. But in other cases, like a community resilience hub or a hospital or essential services like emergency responders, it can be hard to put a dollar sign on that level of resilience. But really coming to a way where we can commonly value resilience, whether it has a dollar sign in front of it or not, is critical to the fundamental justification of putting in microgrids. And there's opportunity there as well.
Thank you, Amy. Sorry, I'm back, and Don, I'll let you respond.
Okay, yeah, it's a really interesting question, and we as a company, we're trying to eliminate some of the whether it's the technical challenges or the business challenges that are the barrier to deployment. And I'll give you an example of two things that we're doing. We have we've done over 300 microgrids in North America, and most of them are engineered to order, much like what Amy talked about. But we are developing a new set of technology that's more, I'll say it, configured to order. So we are containerizing microgrids, putting the controls in a box, factory engineered, validated, and tested, so that we can not have a standard microgrid that you can deploy thousands of them, but you can configure them. It takes months off the engineering time, where we can now put certain styles of microgrids together from the controls very rapidly, deploy them very rapidly, deliver the controls. So in essence, you put them in the field, you plug in your solar, you plug in your battery, you plug in whatever your generator based on how it's been defined, and it will work in weeks rather than months. So we're doing that. As the second thing that we're doing, which I think is pretty important, is we're trying to eliminate one of the hugest barriers, which is the upfront cost. And we've developed a microgrid as a service, energy as a service business model, where we've created 2 affiliate companies. One's called Green Structure, one's called Alpha Structure, where we will come and say, no upfront cost whatsoever. We will design, build, own, operate, and maintain the microgrid. And we'll do that with financial partners. It's not financing a microgrid. It's providing the whole off-balance sheet microgrid capability for commercial industrial customers, and we become a partner for a long-term capability. We've done this in conjunction with Duke Energy on the East Coast. We've done it with NextEra on the South, and I actually think it'll be with the program that Deb provided. I think it's something that I want to talk to Xcel Energy about in the future. So next.
Yeah, and if I could just jump in on this question of kind of challenges, thinking about it from the utility side, utility rules or tariffs can be a barrier to projects. And so that's something that we thought a lot about as we were trying to propose a program here. We have some experience with doing one-off projects, but not with sort of trying to standardize the ability to have microgrid projects throughout our territory. And so that caused us to propose a couple of things, including like ownership of distribution infrastructure behind the meter, right? So for example, if you are a customer today, you have multiple buildings that are all served by the utility. If you want to make that into a microgrid under our rules today, right, maybe you're going to try to put that all behind one meter, you would then need to buy all of that distribution infrastructure from the utility, which is a barrier to doing the project, right? And so one of the ways that we thought of to try to address that would be, well, what if we just keep owning that infrastructure and you pay us the appropriate rate for that? But, there's no reason that we could think of that we should continue to sort of leave that barrier in place, right? And so those types of things are things that I think as utilities start to look ahead at these types of projects and what they really mean, and what it means to really facilitate something like a microgrid, looking at the rules that are in place today is going to be a big part of that.
I'm going to switch gears a little bit and take a question from the audience. This is a question for Amy. Please talk about optimizing energy dispatch with a real-time interface. So if you could talk about how your controller analytics platform works with what's happening minute by minute on the field and how all of that comes together.
Yeah, so the best way to, when we talk about energy optimization, really we're looking at that grid connected mode. We're looking at making sure that you get the most bang for your buck. And that really means playing against the rate tariff. If the rate tariff sets the rules of the game, how you're going to win that game. And the best way to do that is through modeling, is through a computer model. Most rate tariffs out there these days are complex enough. Most commercial rate tariffs these days are complex enough that it's hard to just think about it. And if you just thought hard enough, you could say like how you should operate the system. And so now that you're into a computer, even more than using just a straight up algorithm, using mathematical optimization, and I mean that in the most rigorous mathematical sense of the term, to simultaneously solve what your targets are, where you're going at any given moment with the system in order to have the maximum economic benefits. We often see that these that projects today, and this could obviously evolve in the future as the field evolves, but today projects are cost justified on the edge of a knife, and just a few extra, cents, a few extra, 1 extra kilowatt of demand that's shaved off can make or break a project. And so we do that optimization when we do the design phase. And we predict how the system should be run. But then when we're doing actual controls, we use a similar process with a little more caveat to first optimize how we think we should be operating based on historical data, based on what the building is doing at the time, but then also adapting to what's happening in real time. And, you can perfectly predict what you should have done if you have enough historical data. But a lot of what comes into it then is what happens if you miss? What happens if you miss by how much in terms of demand windows or time of use windows? It depends on how complicated the rate tariff is. And all of that is, what we're working on here at muGrid. We're working on it in Wisconsin at a handful of different types of sites, all with those unique different types of needs. But being able to adaptively control a system instead of making a set rules-based system addresses some of that challenge and opportunity we talked about of uniqueness, because not only is it uniqueness about the site in general, but it's a dynamic uniqueness, what is happening right now in terms of what the load is and what the resource is available.
Don, if I can get you to respond in 2 minutes. Amy talked about optimization in grid connected mode. Could you talk about optimization for islanded mode where resilience?
Sure. It's all about adaptive analytics from our perspective. I mean, our controls, our software, the experience that we've had, when we go into an islanded mode, we look at weather, we look at historical information, we look at available resources and loads on the grid, or I'm sorry, behind the meter. And we just have to optimize it. And our algorithms learn every day. So our microgrids operate more efficiently tomorrow than they did today. Next week, they're going to run more effectively. So we have to just look at adaptive things and just analyze everything on a day-to-day basis. And we'll even provide, as a routine basis, we provide 15-day plans ahead of time, so that the microgrid sort of knows what it should be doing, and then it does what it needs to do and evaluates. So to me, it's all about the combination of OT, IT, and digitization, and making sure that everything works. And it doesn't have to be, it does this behind the scenes as well. I mean, it's not like somebody has to sit there and manage the microgrid. If we're doing things correctly, it just operates, right? Much like a breaker operates, to prevent a fire, a microgrid should operate just to optimize the sequence of operation and the analytics that the rules are, as Amy said about the tariffs.
Thank you.
Yeah.
Oh, go ahead.
Heather, can I just jump in a little bit? Yeah, just wanted to respond a little bit to some of the things that you both mentioned. Obviously utilities care a lot about the rates and tariffs that are in place. And, I think it's fair how Amy characterized that as, obviously you're trying to maximize the benefit for the customer, for that specific microgrid project. But to the extent that the customer is trying to sort of quote unquote win that game, we don't want losers on the other side of that game, right? And so that's where the utility is thinking through whether the rates and the rules and the tariffs are fair ultimately to everyone, because what we don't want is a situation where, you can justify a project, but somehow that causes costs or is detrimental to other customers, right? And so just wanted to make sure that that point was made.
Yeah, absolutely. As a quick follow on, since I said the winning the game thing, it should be a win-win situation. And we on the analytics side, which we're usually working on the customer side, although we have worked on utility side in the past. We assume that the utility is setting up those rules, the rate tariff rules, to incentivize the behavior that they want to see that is beneficial to the utility, yes, as a company, but also the collective. That the utility is really balancing across the entire system view that an individual customer can't see. And the rate tariff provides the knobs, and the rate tariff and any incentive programs provides knobs that the utility can turn to say, hey, in order for the good of the collective, this is how we want our individual subscribers to behave, and how they could help us out. And I usually call the rate tariff is the stick, because it's what you pay. And any incentive programs are the carrot. We'll pay you to provide demand response, or other programs like that. So that sets it up, as a little bit of a competition, but it should be a win-win situation. It should be the utility's hat is the good of the collective, and the consumer's hat is the good of the individual, and they should work together. There are win-win situations here.
We're
just to jump in a little bit. I think what we need to get to and will get to is continued evolution of what those, rate designs and programs and those types of things are, right? And I think the more sophisticated we can all get with that, the more likely we are to be able to realize sort of all of the benefits that I think we're talking about.
If I can add one thing too, I mean, we're leaving out a big stakeholder here in the conversation. We've talked about the role of the utility. We've talked about the role of the providers, like Amy and myself. We've talked about the consumer, the customer. We have to also remember the regulator, right? Because the utility commission sets a lot of the rules that the utility has to abide by. And I think there's a lot of room for improvement in educating our utility commissions, not only in Wisconsin, but in all 50 states, and getting some proactive things done to make it easier for everyone to operate in a fair, equitable, and more just a better economic way.
Thank you. In the interest of time, I think we're close to the end of our time slot, and I apologize for all my Wi-Fi issues. I do need a resilient internet connection, if not anything. I'd like to thank our wonderful panel of speakers, audience members, our support team. Special thanks to our sponsor, Xcel Energy, for this session. Just as concluding remarks, I think we are at the transformative time in the microgrid market. I think in 2020, we saw both opportunities and challenges. Nationally, we saw how severe weather events such as hurricanes and wildfires lead to outages and shutoffs. But we also had encouraging news. The California Public Utility Commission's microgrid proceedings also stand to be a bellwether for everything that's happening nationally. So I'm personally excited about this, and also looking forward to more technology standardization, and also the growth of behind the meter microgrid market. So thank you all for listening. This was wonderful. Thank you again for joining us, and tune in for the next session. Have a nice day.
Bye, everybody. Nice talking with you.